Good morning, students. So this is the fourth lecture on chapter 8. We are done with chapter 8. So this is the last lecture or the last session, we can say. So today we are going to go over some practice problems. So to have some more practice on chapter 8 on friction problems. So by now we are all clear about how does the friction acts and how do we apply friction concepts on the problem solving. Okay, so if you go to your handout, so the handout is already there on the blackboard. So this is the problem 1 of your handout. Okay, so this is problem 1. The system is as shown. So let's go through the statement. The winch on the truck is used to hoist the garbage bin onto the bed of the truck. If the loaded bin has a weight of 8,500 pounds and the center of gravity at G, determine the force in the cable needed to begin the lift. The coefficients of static friction at A and B are 0.3 and 0.2 respectively. Neglect the height of the support at point A. Okay, so this is the system. We have a truck and this garbage bin with a weight of how much? 8,500 pounds with the center of gravity. So this is the center of gravity of this garbage bin. Okay, the dimensions are as shown, and we have these 2 points, point A and point B. Point A is on the ground surface, and point B is on this inclined surface, right? And then we have this cable which is trying to pull this garbage bin and load it onto the truck. Okay, so this is the system. Now, what do we need to find? We have the coefficient of static friction at point A and point B, and we need to determine the force in the cable, right? So that's what we need. Okay, so we can apply the coefficient of the concepts of friction coefficient, friction force, and motion, right? Okay, so let's apply those concepts and let's try to find out how do we find the tension in the cable. Okay, so as a first step, we know what is the first step, right? First step, we need the free body diagram. So draw the free body diagram of the system. Okay, so I'm not going to draw a fancy diagram. I'll just draw this diagram like this. Okay, so this is your garbage bin, just a rectangle. Okay, now what are the forces? Let's use different color. Okay, now this is your point G, which is the center of gravity of this garbage bin. Okay, and the weight of this bin is acting through the center of gravity. Okay, so the weight is 8,500 pounds. Okay, what else? So this is your point A, right? This is your point A, okay, and this is your point B. Okay, this is your point B. Now we know what are the forces acting at point A and point B, right? So at point A we have a normal force. So it's resting on this ground surface. So we have N sub A, right? And we have the friction force, right? So friction force, you can say that this is the friction force. Now this bin is moving into this direction, right? So it's moving in this direction. So the friction force is always opposite to the direction of move, right? So where's the direction of move? It's in positive x direction. So this is the direction of F sub A, right? The friction force at point A. And we know that this is equals to mu A times NA. So we can say that FA equals 0.3, which is the coefficient of friction at point A, times n sub a. Okay, so this is our f sub a. Okay, now once we come to the point B, now if you look at the system, if you look at the original diagram which is given, so point B is onto that inclined surface, right? So the contact surface is at an angle of 30 degrees from the horizontal, right? So let's say that now this is your n sub b, right? Okay, so this is your NB. Okay, now where is the friction force? Friction force is acting in this direction, right? Parallel to the surface of contact. Okay, and so this is F sub B, and F sub B equals mu sub B times N sub B, right? Which gives you FB equals 0.2 times NB. Okay, so this is your friction force at point B. Now we have another force, which is the force in the cable or tension in the cable, right? Also acting at 30 degrees from the horizontal, right? So let's use a different color to differentiate between the friction force and the tension in the cable. So this is the tension in the cable, T, right? And this is at an angle of 30 degrees. Okay. So now we need to find this T, which is the tension in the cable, to see that what force or what tension do we require in the cable to load this bin onto the truck. Okay, so this is our free body diagram. So now with this, we are done with the free body diagram. So now we can go to the next step, right? So next step is apply the equations of equilibrium. Apply the equations of equilibrium, right? Okay, so with that, first thing, let's take counterclockwise positive. Let's take sigma mb equals to 0. Okay, so let's take moment at point B so that we can neglect FB, NB, and T, right? So the only, and also FA, right? So let's see, let's take moment at point B equals to 0. So what forces will create moment at point B? If you look at the free body diagram, we only have two forces which are creating moment at point B, right? One is N sub A, and the second one is the weight of the bin, right? W. Okay, so what do we get for sigma mb? We get 8,500 times 12, which is the moment arm, right? It's counterclockwise, so it's a positive moment. Then we have N sub A creating clockwise moment, so it's a negative moment. N sub A times 22 equals to 0. Okay, so this is the equation for moments at point B, and from here we can directly get N sub A, which is 4,636.3 pounds. So with this moment at point B, we get the value of N sub A. Okay, so we are done with this moment equation at point B. What next? So next we can apply sigma fx equals to 0. Okay, so if you do that, what do you get? X component of the tension force, tension in the cable, so T cosine of 30 degrees. Then this the X component of F sub B, which is 0.2 times NB times cosine of 30 degrees. Then we have the x component of n sub b, which is nb times sine of 30. Okay. Then we have what else do we have? Sigma f x. We have f sub a, right? So f sub a, which is 0.3 times n sub a, 4,636.3 pounds equals to 0. Okay, so these are 1, 2, 3, and 4 forces acting in the x direction. So we include all these 4 forces in sigma fx equals to 0. Okay, so if we do that, we just simplify this equation a little bit. So we get t times 0.866 minus 0.673 2 times nb equals 1,390.9. Okay, so let's take this as our equation 1. Okay, because we don't have the value of nb and we don't have the tension in the cable, so we have 2 unknowns, right? Okay, so now use the next equation. Let's apply upward positive sign convention, sigma fy equals to 0. Okay, if you do that, what forces do we have in y direction? We have the weight, we have n sub a, we have the y component of n sub b, we have the y component of t, we have y component of f sub b, right? So we have so many forces. Okay, so let's include them all, and let's write the equation of sigma fy. So we have 4,636.3, right? Then we have the weight, 8,500 pounds. Then we have the y component of the tension in the cable, so t times sine of 30. Okay, then we have the y component of n sub b, so nb times cosine of 30 degrees. And then we have the y component of f sub b, right? So negative 0.2 times nb times sine of 30 equals to 0. So we have this 1, 2, 3, 4, 5 forces in y direction. So we sum them up, these 5 forces, to get our sigma fy equals to 0. Okay, so if you just simplify this equation, you get t times 0.5 plus 0.766 times n sub b equals 3,863.6. Okay, let's make it our equation 2. So now equation 1 and equation 2, we only have 2 unknowns, which are the tension force in the cable T and n sub b, the normal force at point B, right? So 2 equations, 2 unknowns. We can just solve these 2 equations and get these 2 unknowns, right? So you can solve these equations with any method you like, and we can say this is the third part. So third part of the problem. Equations 1 and 2, we get, what do we get? We get T equals 3,000 3,666.5 pounds. Okay, or we can say 3.67. This is your T. Okay, and also we get N sub B, which is 2,650 pounds. Okay, so that's how we are done with this problem 1 of your handout. We wanted to find out this tension force in the cable to load this garbage bin onto the truck, and we found out applying the equations of equilibrium to the free body diagram using friction equations and equations of equilibrium. We found out what is the tension in the cable which is required. So it's 3,666 pounds, or we can say 3.67 kips, which is a kilopound. Okay, so that's how we are done with this problem. Now let's move over to the second problem of your handout. Okay, so let's do problem 2 of your handout. Okay, so if you go through the statement, the beam AB has